Good morning, all of you. Today we will be doing or practicing the previous year's questions. From 2004 onwards, we'll be discussing the question papers, board questions, different types of questions, and different types of numericals also of chapter 2. First question, mention a large scale use of the phenomenon called reverse osmosis. This is, of course, desalination of seawater to get potable water. Next, two elements A and B form compounds having molecular formula AB2. Molecular formula of the first compound is AB2 and second is AB4. When dissolved in 20 gram of benzene, 1 gram of AB2 lowers the freezing point by 2.3 Kelvin, whereas 1 gram of AB4 lowers it by 1.3 Kelvin. The molar depression constant for benzene is 5.1. This is for the solvent. This Kf, this value is Kf, that is 5.1 kg per mole. Calculate the atomic masses of A and B. Calculate the atomic masses of A and B. So here, first one AB2 and the second one is AB4. So if you find out the molar mass, then the same is the molecular mass, only the unit is changed. Molar mass unit is grams per mole. Molecular mass in U, but that magnitude is the same. So that magnitude is obtained by A plus B plus B, that is AB2. Just like we find out this molecular mass. Similarly here A plus B plus B plus B plus B. This is AB4. So this you keep in mind. Now we are going to find out the molar mass of AB2 and molar mass of AB4. So first case, that is when dissolved in 20 gram of benzene, that is WA is 20 gram, 1 gram of AB2 lowers the freezing point by 2.3 Kelvin, whereas 1 gram of AB4 lowers it by 1.3 Kelvin. So here 2.3 Kelvin is equal to 2.3 Kelvin. This is delta TF is equal to KF. What is KF? 5.1 into 1 gram divided by molar mass MB, that is for AB2, into 20 gram upon 1000. Okay, so from this you can get the molar mass of AB2. Similarly, you will be calculating for the molar mass of AB4. So here it is written, when dissolved in 20 gram of benzene, 1 gram of AB2 lowers the freezing point by 2.3 and 1 gram of AB4, that AB4 lowers it by 1.3 Kelvin. 1.3 is equal to, again it is benzene, so 5.1 is the same, 1 gram its molar mass. So I am writing it as Mb1, here it is Mb2. Or I'll change AB to molar mass, that is here AB2 and here it is AB4. Again 20 upon 1000. So by using this you can find out the molar mass of AB2 and the molar mass of AB4. So the molar mass of AB2 and AB4, after calculation you will be getting it as AB2 value, you are getting it as okay, I'm changing it. After doing this calculation, AB AB2, you will be getting it as 110.8 gram per mole, and AB4 you will be getting as 196 grams per mole. What is AB2? That is A plus 2B. A plus B means A plus 2B is equal to 110.8. And AB4, that is A plus 4B. B plus B plus B plus B. B plus B plus B plus B. B. So this is 1.196. So you can solve these two equations. You can equation number 1, equation number 2. So you do one thing, subtract equation number 1 from equation number 2. So what you have to do? 2 minus 1. 2 minus 1. So you will be getting as 2b is equal to, so 196. 196 minus 110.8. So you'll be getting some 85.2, 196 196 minus 110.8, 5, then 85.2. So B is equal to, B you are getting, that is this divided by 2, 85.2 divided by 2, that is 4, then 2.6. So B you got. So this is the atomic mass of B. What is the atomic mass of A? You substitute this B value in any of this above equation. B value, that is A plus 2B. A plus what is 2B? 85.2. 85.2 is equal to 110.8. So you can find out A. A is equal to 25.5, somewhat 25.5 U. Now, and in the case of atomic mass, you will be giving the unit U. Molar mass, the unit is grams per mole. Atomic mass, the unit is U. So this way you have to find out. First you have to find out the molar masses of AB2 and AB4. Then you solve these two equations, you will be getting B. Then you can calculate A, atomic masses. Next question, state Henry's law about the solubility, that you know what is the sum of the mole fractions of all the components in a three component system, that is 1. Some three component system or four component system, I component system, that is xa plus xb plus xc etc etc plus xi is equal to 1, means unity. Define mole fraction, that you know, then state the formula relating the gas with its mole fraction in a liquid solution in contact, that you know a solution is made by dissolving. This is a direct question. You can keep it in kilopascal itself, so units will get cancelled, no problem. Or if you want to convert that into pascal, then you can multiply each one by 1000. There's no need of multiplication, because p naught a, that is p naught a minus pa upon p naught a is equal to xb. So here you have to take care that this xb is wb upon mb upon wa upon ma. Don't write here 1000 as in the case of elevation, boiling point, or depression, freezing point. We used to write wa upon 1000. There it was 1000. But here it is wa upon ma. So this you have to take care. It is not 1000, it is ma. But in the case of elevation, boiling point, and depression, freezing point, it is 1000. Normally students make mistake, means we have seen while checking the answer sheets, we have seen students make mistake at this point. Then the next question what I cut is Van Hoos factor, that is not in your syllabus. State Henry's law, okay, explain the significance of Henry's law constants. As KH increases, solubility decreases. That is the significance. At the same temperature, hydrogen is more soluble in water than helium. Hydrogen is more soluble means KH value is lower. Helium is less soluble. That means KH value is higher. Helium is less soluble means KH value is higher. Which of them will have higher value of KH? Higher value of KH, that is for helium. Why? As KH increases, KH and solubility are inversely proportional. Two liquids A and B boil at 145 degrees Celsius and 190 degrees Celsius respectively. Which of them have higher vapor pressure at 80 degree Celsius? For that we are taking that graph, that is vapor pressure. This is the atmospheric pressure, 1 atm, the same graph 1 atm. Then here it is temperature. Temperature is marked on x-axis. Now we had that for solvent, this is the curve for solvent, and for solution down curve, this solution. Now this is the boiling point of the solution, this is solution, and this is the boiling point of the solvent. So two boiling points are given for solvent as well as for solution. Now they are telling, okay, two liquids are given. So one is solvent A, one is solvent A, and the other is solvent B. Two liquids, liquid A and liquid B. So take in that way, liquid A and liquid B. Liquid A and liquid B. This is liquid B. Now A boils at 145. A boils at 145 and B boils at 190. Why A boiled at 145 degrees Celsius? Because its vapor pressure is higher. Vapor pressure is already higher means boiling point is lower. So vapor pressure, liquid A's vapor pressure was always higher. Liquid A boils at 145 means its vapor pressure is always higher. See the graph? Vapor pressure is having. So at this point, liquid A's vapor pressure is higher. At this point, Liquid A's vapor pressure is higher. Always liquid A's vapor pressure is higher. So they have asked higher vapor pressure at 80 degrees Celsius. Suppose this is 80 degrees Celsius. At 80 degrees Celsius, see, vapor pressure. Vapor pressure of liquid A is higher, vapor pressure of liquid B is lower. So from this graph, you can make out which is having higher vapor pressure. So liquid A is having higher vapor pressure. Next question. Why is the vapor pressure of a solution of glucose in water lower than that of water? Of course, lower than that of water means some of the surface area of covered by some of the surface area of the solution, that solvent that surface is covered by this glucose molecule. So that's why this vapor pressure is lower. Now next question, that is this one we have already done. Then urea forms, this is a direct question. This is P naught A minus PA upon P naught A is equal to, here it is given, this you have to find out that XB. Here 10% means the percent, seeing percent, you have to consider what? 100 gram of solution. 100 gram of solution. So 100 gram of solution, in that 10 gram is solute. 10 gram 10 gram is solute, so 90 gram is solvent. 90 gram is solvent. So that XB, that is P naught A minus PA upon P naught A. P naught A is given. PA you have to calculate. Urea it is given. Urea, the molar mass is 60. So 10 upon 60 whole divided by 90 upon 18. That is the MA. Urea forms ideal solution in water, they said, water. So 18 is the molar mass. WA upon MA. MA is 18. Water's molar mass is 18. Urea you can calculate, that is urea 16 NH2CO NH2. This is the formula you can calculate. So PA you have to find out. P naught A minus PA upon P naught A. P naught A is given. You can find out PA. Next question. Why is freezing point depression of 0.1 molar sodium chloride? This we have already discussed. Sodium chloride dissociates into Na plus and Cl minus. So if you are putting, how many you are putting? 0.1 mole. 0.1 mole you are putting in 1000 ml solution is there. So 0.1 mole if you are putting sodium chloride will give you how many particles? Double. That is 0.2. As the concentration increases, 0.2 moles, freezing point, depression. Why is freezing point depression? Nearly twice. So what happens? 0.2 moles, when when 0.2 moles means more amount of surface area is covered, means vapor pressure will be less. Double the particles, double the actually particles number is double, so vapor pressure is halved. So vapor pressure come ho gaya, means vapor pressure became lower. So you have to heat and heat and heat. You have to heat and heat and heat. So the solutions, that delta TB will be double. Delta TB, freezing point depression, delta TB will be doubled. You know that as vapor pressure decreases, as vapor pressure decreases, boiling point increases. Now 2007, define osmosis. You know, definition of osmosis. Next, antifreeze. This is direct question, no problem. Then here, a 0.1539 molal aqueous solution of cane sugar has freezing point Solution's freezing point is 271 Kelvin. While the freezing point of pure water, so there is freezing point depression. This is of pure water. This is T naught F. This is TF. What will be the freezing point of an aqueous solution containing 5 gram of glucose per 100 gram of solution? We have 100 gram of solution. So this is small l, small m, small m. What will be the freezing point of an aqueous solution? So first they have given cane sugar solution. Its freezing point is 271. 271, and while the freezing point of pure water. So here delta TF, you can find out the difference between this delta TF. Delta TF is equal to KF into molality. So delta TF is given. You can find the difference between these two, and molality directly given, so you can find out kf of water is not given. If you know by heart, then it is okay. Kf you have to calculate, and using this kf you have to find out the next portion. That is, next portion means what will be the freezing point of an aqueous solution. So here you will be writing what? T naught F minus Tf. What will be the freezing point of the aqueous solution? You have to find out Tf. T naught F minus Tf is equal to Kf you are getting from here. Kf you will be substituting here. And Wb upon Mb. What is Wb? That is 5 gram upon Mb. What is the Mb of cane sugar? That is 342. 342, you can cane sugar is C12H22O11. It's given 342. What will be the freezing point of an aqueous solution containing 5 gram of glucose? So it is not 342, it is 180 glucose. This is 180. Kf is for water. Kf is for water. They change the solution. 5 gram of glucose. This is 180. 180 per 100 gram of solution. So what is the amount of solvent? Solvent is 95 gram. 95 upon 1000. So this Kf, you know, rest everything is here. T naught F. T naught F is that is 273 Kelvin. T naught F. 20 degrees Celsius means 273 Kelvin. So you can find out TF. You can write TF in Kelvin, or if you want to put in degrees Celsius, that also is possible. So you have to find out what? You have to find out this TF. T naught F 0 degrees Celsius means 273 Kelvin. So first portion, using the cane sugar, you found out KF, and KF is for water. So here again the solution is made in water only. So here Kf you can substitute, that Kf value you can substitute and find out. Then in 2008 there is nothing, no problem in this. Positive deviation. Define osmotic pressure. Describe how the molecular mass of a substance can be determined on the basis of osmotic pressure measurement. So you can derive that equation, pi v is equal to NBRT. From there you can derive an equation for MB. Then the next question, it is a direct question. Then calculate the temperature at which a solution of 54 gram of glucose means C12H22, C6H12O6 in 250 gram of water. Calculate the temperature at which a solution containing this much glucose. So you have to find out what this freeze, that is TF, you have to find out TF. So equation is similar to the previous one, that is T naught F minus TF is equal to Kf into molarity, that is Wb upon Mb into Wa upon 1000. So here you have to find out what, calculate the temperature at which the solution containing will freeze. So Tf you have to find out. T naught F, that is 0 degrees Celsius, means 273 Kelvin. This is 273 Kelvin. Kf is given. Kf is given. This Kf only we were finding out in this question. This Kf only we were finding out this question, that is 1.6 Kf, 1.86 kg per mole, that is calculated out from this first portion. Okay. So that Kf you will be putting here. Then Wb is 54 grams of glucose, Mb is 180, C6H12O6. You by heart that value 180, then 250 gram of water. So rest everything is there. You can calculate what? TF. TF. Next, state the law correlating. This is gas and its solubility in liquid. That is Henry's law. State an application of this law. Its application is what? That is soda water. Carbon dioxide at high pressure is passed through water to make soda water. Then mole fraction, okay, one household factor is not in your syllabus. This is again 100 milligram. You have to convert that into grams by dividing it by 1000, dissolved in enough water to make 10 ml of a solution. This ml you have to put in liters because it is osmotic pressure. Osmotic pressure, what is the formula? That is pi v is equal to NBRT, or pi v is equal to WB upon MBRT. So here everything you have to convert, the units you have to convert. You convert this pressure into atmospheric pressure because it is given in terms of liter atmosphere per Kelvin per mole. So for converting this millimeters of Hg into 1 atm, what you have to do? Divide this by 760 mmHg. So pi osmotic pressure is given, that is 13.3 mmHg, means upon 760 will give you this much atmospheric pressure. Volume is what? 10 ml, that is 10 divided by 1000 liters is equal to WB. 100 milligram means 100 upon 1000 gram. 1000 gram, like this conversion. The main problem is here conversion. Then MB, that you have to find out. MB you have to find out. MB. And R is 0.082 R. Temperature is given, that is 25 degrees Celsius, means 298 Kelvin. 298 Kelvin. So rest everything is given. You have to find out this MB. So in osmotic pressure, numerical means there will be a lot of conversions. See, here weight is to be converted. This milligram is to be converted into grams. This volume is to be converted into, this ml is to be converted into liters. And this pressure is to be converted into atmosphere. And this temperature is to be converted into Kelvin. Every conversion. Then R value they have given, normally they don't give this R value because once you convert this mmHg into atmosphere, then you know this value, that is 0.082 liter atmosphere per Kelvin per mole. Suppose they are giving in bar. Suppose they are giving in bar. So bar value 0.083 liter bar per Kelvin per mole. Next, here there is no problem. What concentration? This we have already done. Then in these question also, these all are direct question. Differentiate between molality and molarity. Last year also you learnt molarity is temperature dependent because volume factor is coming in that. This is temperature dependent, temperature independent. Weight is uh, temperature. There is no relation between weight and temperature. So volume and temperature, as temperature increases, volume of the solution increases. So first you give the definition of this, then the temperature dependence also you write in both the cases. Molarity is temperature dependent and molality is temperature independent. And in this question, that is here 15 gram of an unknown molecular substance was dissolved in this much gram of water. The resulting solution is freezing at this much degrees Celsius means the difference. Pure water, pure water freezes at 0 degrees Celsius and the solution minus 0.34. So the difference is 0.34. That you have to put in Kelvin. Difference is the same whether it is in Kelvin or in degrees Celsius. So this difference what you are calculating, that you have to put in Kelvin. So here it will be delta TF. Delta TF will be plus 0.34 Kelvin is equal to. Then you can write Kf is given. Kf of water is given. Better you by heart this value 1.86 kg per mole. Kf is given. So this we have got. And molarity, that is Wb 15 gram. Wb upon Mb you have to calculate. And 450 upon 1000. This way you can calculate Mb. Thank you. We will continue in the next class.